Thank you, everyone, for showing up and for paying more attention to me than the belugas. I know they are amazing over there. Cool. Yeah, so today we're here to talk about Gitops, Policy as Code, and Open Policy Agent. Like I said, my name is Peter. I work for Styra, and we are the founders and maintainers of Open Policy Agent, which is a graduated CNCF project. And so let's just hop into it. So we're going to talk a little bit about what is a policy and why does it matter. We're also going to give a little bit about a history of policy as code, and kind of how we've reached this point in just like the evolution of Gitops. And then we're going to talk about Open Policy Agent specifically and how to use that for policy as code. So let's talk about what is a policy, right? And so this is a policy that most people have probably seen at some point, right? This is a password requirements or password policy where it is, right, the overall rule is that you need a password, and the password must meet all of these requirements, right? So the rule itself is that you need a password, and then, or the rule itself is that you need a complex password, and then each of these individual components make up that rule, right? And there are all kinds of policies that you may encounter as you are you may encounter inside of your organization, right? You can have authorization policies inside of your application. You can have legal policies that say you might have to store data. You might have infrastructure policies that say you can't create, extra large databases on the weekend, right, or something like that. You might have behavioral policies that say you can't tailgate into the building, right? These are all things that, these are all policies or rules that your organization has set. And so when you think of policies they're the rules that kind of define how behavior should happen inside of your organization or inside of your application or inside of your infrastructure. And so policy matters, right? And then so a lot of things happen when you don't, our policy will protect you from a lot of things, right? They're going to protect you from those runaway services, from CI/CD pipelines creating a bunch of resources that you don't need or don't want. They're going to make it easier for collaboration, right? When you have multiple teams working together, and right, being able to share a repo instead of tell someone how things should work, right? It also removes a lot of the cognitive overhead of having to know what should or shouldn't happen, right? There's always the old guy on the team that kind of has all these rules in their head and says, you can do this or you shouldn't do that, and all these rules. But it works so much better when those rules are written down, so then the new engineer just knows what should happen, and it just removes a lot of that stress. And then when you don't have policies, right, like the exact opposite happens, right? This is when things like you can have the same resource created with 100 different configurations. You can have security holes like security groups not patched at all. You could just have general chaos in your infrastructure, right? Like letting things go just unchecked entirely. Right, and so let's talk a little bit about how we've gotten to policy as code. Right, like starting off, like going way back in time, right? Policies may have been something as simple as, right, defined workflows inside of like a wiki or document or just manually verified processes, right? And then at some point, right, you make them just a little bit better, and you might start hard coding your authorization directly inside of your application, right? And now you have these authorization policies inside of your application. And then from there, you might move one step forward and start automating some of these policies so that when services are created, policies get injected into them, right? And so you kind of keep moving forward and making these policies a bigger and better part of your application and services, right? And now with policy as code, we are taking that idea and kind of taking it one step further and making the policy its own service or its own product or its own process. And so we end up with, right, like, we end up with policy as code as this thing that becomes, right, its own product, right? Meaning that you are now working on policy as a standalone thing. It's not just a tack onto each of your services, right? Policy needs to be understood throughout your organization, throughout your services and applications, all the way down to the infrastructure, right? And so treating it as a product gives us a lot of kind of benefits, right? The first one here is versioning, right? You want to be able to say anytime that there is a change to your policy that this gets checked into a Git repository, right? So you know that the policy is this week or the policy is last week, and knowing that at any given time, you know what the policy was and why actions were taken when they were taken, right? You also want things to be automated, right? You want to tie a lot of these actions to Git workflows. You want to know that when you do create a change and you do submit it, you want these things to be injected automatically. You want to push to Git, and you want Git to understand how to push all that stuff out for you, right? And then documentation, right? Having all this stuff written as code means that you have your policies in a documented format that you can share, right? And so policy as code versus infrastructure as code, right? And kind of the evolution here, right? And so way back when we had cloud technology first coming out, right? We have infrastructure as a service, right? This is just when we started off with just on-demand resources, compute and storage. This led very quickly to us making infrastructure automations, right? From automations like Puppet and Chef, right? The very imperative mindset around configuring a lot of our infrastructure, right? Being able to say like, oh, turn on, do X, Y, and Z, and at the end of this, you are configured, right? And then we have that imperative mindset shift into declarative, where we have infrastructure as code tools, where now we want to define what we want the end state to be, and we want our infrastructure to match that. It's not turn on and do X, Y, and Z steps. It's you are complete when you've reached this state, right? And then from there, the next evolution is Kubernetes and containers coming out and kind of changing the way that we look at a lot of this stuff. And with Kubernetes, containers replacing a lot of the VMs, right? Now all of a sudden, there is a shift around how we are writing our application and how we are managing that application, right? And so the idea of Gitops comes around, where it is you want to understand, or you want one place that is like the source of truth for your application. You want to understand what the desired state of your Kubernetes cluster is, of your application, and you want that all to be saved in Git, and you want that to be your source of truth for everything. And so if there is drift or changes, you can easily sway back and forth between them, right? And then the extension from there, right, Gitops for Kubernetes, and then moving into Gitops for the control plane, right? Now, you want to always understand what the desired state of your application is. But if that application depends on the underlying infrastructure, you want to understand that that should also be checked into Git alongside of your application manifest. If your application is requiring a certain amount of resources, then right, those resources should be part of the definition of what you are trying to build and the end desired state. And so moving from there, now we have the next extension being policy. So now we have the application, we have the underlying infrastructure, but now we have the behavior, right? And so this is now, policy as code is Gitops for policy, and understanding compliance and authorization and all of those components that need to go into your application and into your infrastructure that allows it to follow your organization's rule sets. And so this is kind of an extension from what was created, but it is a very natural extension, giving us these compliance and governance rule sets around what has already been created, right? And then so let's talk a little bit about, I've said the word Gitops a ton of times, and we haven't actually explained what Gitops is, right? And so here we see a very standard Gitops workflow, right? You as a developer write your code, you push it to a Git repository, and then from there, a bunch of Git magic happens, and resources and applications are created, right? Everything kind of gets pushed out from your GitOps workflows or CI/CD pipelines. Everything happens, right? And so a very not exact definition of GitOps, right? It is a developer-centric approach to managing your applications and systems, right? It is using Git-based workflows to reduce the number of errors from human intervention and improve diagnostics with clear indications of pass or fail at any given step, right? These are the components that kind of allow you to have a workflow for defining your application creation that allows you to work very efficiently. And so this was the concise description given by Weaveworks, right? Describe the desired state of the whole system using a declarative specification for each environment. And so this is, right, and this is why now bringing in policy as part of the desired state makes a lot of sense. Oops, let me close that. And so a lot of the ideas that come with policy as code kind of fit very naturally with the ideas that were created with Gitops, right? And so the ideas that Gitops, or the concepts around Gitops that helped infrastructure as code become hyperscalable and hyperusable and shareable, right, stems very well into the ideas of how we want to manage policy as code and how we want to now be able to create policies for each interaction inside of our application and our infrastructure. We want to be able to have a lot of those same hyperscale tendencies that we were having with infrastructure as code, but now for policy as code. And we want to do a lot of the things that come along with Gitops, right? And so here, kind of some of the benefits here, right? Being able to move faster, the ability to be more visible throughout amongst your teams, right? Being able to work with those other teams, being able to be more collaborative, understanding what the security team wants, what the IT team wants, what the operations team wants, and being able to share those policies throughout your team, having more accuracy from this process when security teams or operations team is going to share that information, right? You want to make sure that everyone is deploying or operating under the same rules, right? And then, as we said, versioning and then validation now, just being able to, right, like unit test your policies, right? Being able to say, hey, we expect X, Y, and Z to behave in this manner at any given time, right? And being able to say every time I check in my policies, I want to make sure that those unit tests run and these validations happen, right? And then choosing the right tool for the job. And so there are a bunch of different ways to write policies for cloud-native applications. Right, and if you are very cloud-specific, right, it may make sense to choose something like Azure Policy or GCP's policy service, right? And if you are specific to a tool frame or a framework like HashiCorp, right, choosing Sentinel might make sense. Or if your entire shop is Kubernetes-based and you're not doing anything outside of Kubernetes, right, having a Kubernetes-based tool might make sense. But if you are like most cloud stacks, you are very heterogeneous in nature, right? You are going to have a wide variety of tools that you are using. You're going to be programming in a bunch of different languages. You're going to have services built on a bunch of different types of containers. And so that is where a tool like Open Policy Agent makes sense, because Open Policy Agent is a general purpose policy engine, right? And so being a general purpose policy engine is going to come into play for various components in the software development lifecycle, right? You're going to want validation at the design phase, where you are writing your, this could be where you're writing Terraform scripts, or this could be where you're writing your actual application code and you want to validate that syntax is right, or that the things it created are correct, right? So you can have developers create their own checks in the beginning stages, right? You also want OPA to be deployed, or you want policy to be deployed during the CI/CD process. You want your CI/CD process, as it's reaching out to all of your services, right? Typically, you're going to give your CI/CD a lot of access to do a lot of things. And so you want to make sure that when it is making a call out, that those calls are authenticated and that it is completing the right steps. And so you want to have some sort of guardrails around what your CI/CD can actually do, right? And then at the end here, once everything is deployed, you want to make sure that your state is compliant. You want to make sure that the compliance exists for the end state of your application and the end state of your infrastructure. You want to make sure that if there is a drift, that you are able to detect these changes and move them backwards, or move them into the correct state, right? And then so Gitops now with OPA, right, looks very similar to the first slide, except now there's just these OPAs kind of popping up all over the place, right? You just have them, you're going to have them at each different stop along the way. You're going to have OPA being able to help with guardrails around each of these different components by providing easy checks to understand, right, as the developer's writing stuff, as your GitHub actions are running, as your Gitops workflows are compiling things, right, as Kubernetes admission controller, as things come in and things need to be created, but then also to check Kubernetes state in the end as you are creating infrastructure on AWS and GCP. You want each of these components to know what is or is not within the policy. Right, and then so how does Open Policy Agent work, and will it work with my tech stack? Right, and so the reason that it works in all of these different components is that it is a decoupled policy engine. And so by decoupled, right, this is something that I think we've all seen more and more as an industry trend, is just being able to remove a component from a bunch of different services to do it in one place, right? This idea of being decoupled allows us to have all the services on the left here, on the left here, be able to use the same thing, right? And so now your Kubernetes systems and your dashboards can all, right, speak the same language when they are talking about policy, right? So a decoupled policy engine can sit in one place. Typically, it will sit in a lot of places for performance reasons, but it could sit in one place where they all reach out and basically run are validated against the same types of policies. And so you're able to do this because the policy engine is just looking for JSON data in, right? It takes JSON data in and sends JSON back. So just another view of this, right? Like understanding that when you are deploying OPA, this can be as next to your services, right? If you are running Kubernetes, this can be various points. This could be as like a sidecar container. If you are running libraries, it could just be directly in your libraries. Then they just take in the policy and any data along with them. Right, and then benefits from decoupling, you have the ability to centralize a lot of the control, being able to show, or being able to control everything from one place, being able to write your policies and deploy them throughout your entire system, having these policies be very understood, easily being understood by being written in a declarative fashion, making it so that everyone can understand what's happening, being shared amongst the different services and frameworks that you are using, so that there is just one language that is being spoken, and then being able to treat your products with their own life cycle separate from your application life cycle, being able to say that as my application is updated, that does not affect my policies. And as my policies are updated, right, those can get rolled out without having to roll a new version of my application. Right, and then deploying this with OPA kind of shows you that, like, for each different component, right, you can have these OPAs in various spots. And so for any of these services, right, being able to reach out and use it. And all right, and so now I'm just going to show a quick demo here. How do I minimize this? Cool. And so the tool that I'm using here is StyraDAS. You don't need StyraDAS. You could hand roll the same process by pushing to GitHub, having a GitHub actions, which compiles the bundle and then ships it to like an S3 bucket, and then you could have OPA pull it down from there. This is just a control plane StyraDAS that kind of does the same thing. And so here we can kind of see what my policy looks like. Right, this is a very simple policy. We are going to default to allow equals false, meaning we want to default close. Right, we want to default close. And we have one rule in here. We're only allowing one endpoint, which is the finance salary for username. And so with that, this is just saying that if you are asking for a salary, it has to be your username. And so we should be able to, this should be running. Started this morning and just hope that it would still be running now, and it is. So let's exec into this. Cool, yeah. All right, and so with this policy in place, we can see that we should be able to get that information. So let's just grab this curl here. right? And then, so this is just saying that Alice is asking for Alice's password, which is true. Alice is asking for Bob's password. No, that's not right. Alice is, maybe I screwed up my demo. Let me try something else. Let me just say HR dashboard. Well, I seem to have broken something. Let me check something. Yeah. Okay. Strange. Okay, well, now everything is allowed in. Apparently, it's defaulting open instead of defaulting close. So unless I change something. Let's just try to add a new rule. Let's try to make a change. So draft, push, GitHub, let's see. Hopefully allow default close. Default close. Let's see this. Push changes. Right, very, in the Gitops way of doing things, push this out to a repository, make your pull request, submit it, and merge it in. Cool. And that should be running. Oh, wait, delete that. Cool. And so with that running, let's actually go over here. Settings, deployment. Waiting for sync. Oh, that is why they fell out of sync. So my demo is now invalid for some reason. OK, well, let's just imagine that with these rules, as they get compiled, they then get rolled out to Kubernetes, and they pick up these changes, and we are allowed to either access or not access the endpoints that you're supposed to. And then, so the next part of this was to add a couple more rules, but they're not currently rolling out, and I have to figure out why. So I will fix this demo at another time. I think we are running short on time anyway, so I will just open up the floor to questions if anyone has any. Yes? Ravi's on the way.
Sound check? Oh my God. So we use Terraform Sentinel on a bunch of repos, check for things like botched configs and what have you. And we'll run it both in an enforcement mode where it'll just straight up refuse to allow a plan to go forward, but also in an advisory role where maybe you don't want to do this thing, you should pay attention to it, but I'm not going to stop you. Does OPA have the same concepts where it could sort of advise that things have gone off the rails, or where, and I'm seeing an affirmative nod, so that's a yes?
Yeah, and so for most policies, when you are rolling them out, right, you are going to want to say something like validate, right? And kind of just say, you can validate it against things that are currently existing, or you can just put it into a watch mode, where all of the rules will just kind of say, just watch, right? If it hits something, then log it in the decision log, say that you noticed it, right? Say that this would have failed, right? And so you have those different modes of either you're running the rule saying, just mark these as suspicious, or you're saying, just watch these and say this would have been denied, right? And so those are just different modes that you can set.
Thank you.
Cool, thank you for the question. Cool, any other questions? Yes?
Oh, there you go. It's like whack-a-mole.
Just making you run all around, Ravi.
My steps in.
Hi, my question is, policy as a code is making it easier to centralize all the policy at one place.
Yes.
But isn't it making harder to integrate?
So in a way, I guess it is, because there is a little bit more setup around, right, making sure that all of your applications and services are connected to the centralized repository. But what you get out of that is that, right, so now let's imagine that you do have a change, right? Alice is no longer allowed in the system and you make that change. And so what ends up happening is now you have to go into the finance system, into the payroll system, into all these different systems to change it, to remove that access, versus updating it in one spot. So you're either doing the work up front where you get all of the systems to talk to one place, or you're doing all of that work every time where anytime there is an update, you have to go to every single one. So yes, there is more upfront work, but that saves you time from having to repeat work later on.
Enforcement, how do you ensure the enforcement?
I'm sorry, say again?
The centralized part is good. Integration part, we know that it is difficult. But how do we ensure the enforcement, like to extend a question as a preventive measure than a reactive thing?
Preventive versus reactive measures. And so I guess there, it depends, right? You are going to be writing your policies in a way where you want to where you should have some idea of the actions that are going to be taken. And so if you want things to be more proactive, right, you should write more rules than less, right? Don't write a rule after something bad has happened and then say, oh, that isn't allowed, right? You want to at least create rules to watch all of these actions, right? At least say that, oh, there are 10 endpoints. Make sure that there is at least a rule watching all of those endpoints, and then you at least have a log that says, oh, I saw these actions come in, even though I didn't stop them, right? But at least you saw the actions come in. But until you know that those actions are bad and then you create the rules that stop them, it's harder. You have to kind of do a lot more of the planning up front for your policies. Cool. Thank you for the question.
Actually, I have a couple questions. So I work at a company with 40,000 employees and probably 15,000 engineers. So would it be advisable to try to create some sort of a central open policy sort of repository that everybody shared? Or would you let each business unit, maybe like all 100 business units sort of be responsible for creating and maintaining their own sort of policy repository?
So with OPA, right, you have the language called Rego. And actually, I think I just skipped that slide. Yeah. And so with Rego, right, Rego is a full-featured programming language purpose-built for policy. And essentially what that means is you have things like packages, right? And being able to use a package, right, means that each team might have their own subsection of that package where each team can make callouts to the next, right? So if your ops team has their own sets of policies that they're using, those can now be called from other parts or other teams that are creating their own policies, right? And so this allows you to share those components without having them overlap and step on each other's toes.
Okay. All right, that's interesting. Also, to go along with that, we have a lot of legacy applications that have been around for like 5, 10, 15 years. So I would imagine like migrating to something like this where you're pushing policy decisions into a policy agent, we'd have to go through a lot of code and try to find all kinds of embedded policies that were sort of written as code and sort of pull those out, right?
Yeah, and it is easier for when you're creating new things, right? It's easier to say like, yeah, before anything is created, make sure you match this policy. But when you have a lot of things that already exist, you have to think, how have we secured this in the past, right? And so that's when like the lift and shift happens, where it's like, okay, well, this thing turns down request every time these actions happen. And so you have to figure out how does it do that? You pull that action out, and instead then you tell it to call out to OPA instead of doing before it does that action, right? And so you're starting to remove the policy from the business logic and move it over to OPA, but it is a slow process for sure.
Sure. And even in the case where you have like the OPA embedded as a library inside the application, in that case, is there still any sort of central infrastructure, or is it solely the OPA that's embedded with the library, and then there's like the policy configuration language in the code base? Is that all there is to it, or is there still a central mechanism?
Right, and so the OPA running in the code base or the standalone service, either way, it's going to have management APIs, and so you could run it as a standalone thing inside of that service, Or you could make use of the management APIs, and the management APIs allow you to do things like centralize bundle policies, meaning that it can pull down the latest policy or send out the decision loggings, right? And so those management APIs are kind of how those connections happen, and you can do that same centralized approach with either deployment model.
Interesting. Okay, awesome, thanks.
Cool, thank you for the questions.
Anybody else? I know they're going to open up the room in a second, but anybody has a last minute question?